In 1977, they sent a spacecraft that was only supposed to operate for a few years. But today, it is in interstellar space, farther than any object ever made by humans. And recently, it transmitted data that left scientists baffled. We're talking about the Voyager 1 probe. In the new images and measurements, researchers noticed strange structures and objects, the origin of which no one can explain yet. They appear beyond the solar system, in a region where, in theory, it should be almost empty. But the data shows something completely different. According to NASA, the probe's instruments detect unexpected anomalies and dense structures of matter that simply shouldn't be there. What is it really, a rare cosmic phenomenon? An unknown type of interstellar medium? Or something even more mysterious? And the most amazing thing is that this data keeps coming in right now. Let's see what exactly Voyager 1 discovered at the edge of our solar system.
Even though both Voyager 1 and Voyager 2 spacecraft began their mission back in 1977, we are still receiving a lot of valuable information from them. Initially, it was planned that both spacecraft would explore Jupiter and Saturn, as well as to some extent Neptune and Uranus. No one expected that Voyager would go beyond the original plan. Now they have already crossed the heliosphere, and to leave the entire solar system behind, they just need to get past the Oort cloud. Each Voyager has its own power sources. These are cylindrical structures containing 4.5 kilograms of plutonium. They are called radioisotope thermoelectric generators, and each Voyager has 3 of them. The plutonium produces 2,400 watts. This is then converted into electrical energy. Since the power sources were installed 2 years before the Voyagers began their missions, they've been operating for 47 years. As you can imagine, the operational lifespan has to come to an end at some point. To this factor, we should also add the influence of the external environment and neutron radiation, which appears during the decay of plutonium. This ultimately leads to the deterioration of the 2 spacecraft, and over time, they will transmit increasingly weaker signals. The half-life of plutonium-238 is 88 years, which results in the generator's performance being reduced by half. At the same time, they have to keep all the components running and deliver information to our planet. The maximum amount of memory that the camera images can occupy is 67 megabytes. The devices have 8-bit processors with a clock speed of up to 6.4 megahertz. That's not a lot, considering that, for example, our smartphone has about 380 megahertz. Despite this, the Voyagers were able to gather a lot of information. They still haven't stopped doing it. How did the Voyager project come about? What important scientific discoveries did these probes make? What does the audio recording of interstellar space sound like? And what will happen to these legendary spacecraft in the future? The story begins in 1964. Edward Carroll Stone, who was an intern at the Jet Propulsion Laboratory at the time, came to this conclusion while modeling the positions of the planets for the coming decades. At the end of the 1970s, the planets beyond the asteroid belt would converge in a small part of the sky. This would make it possible to approach each planet in turn, using only gravitational maneuvers to study all the celestial bodies in a short period of time. It would be possible to fly by all of them, not in 13 years, but in just 8. That's why we could get more valuable information. Partly thanks to such a discovery, the Voyager project was created. It was impossible to observe most of the planets from Earth, even with powerful devices. That's why the data obtained by the Voyagers during their missions is so valuable to the scientific community. Voyager 1 was already near Jupiter in 1979. That's when we got images of the well-known Great Red Spot. Voyager 1 also studied Io and noticed that there was volcanic activity on the moon. It even managed to see and record an eruption. At the same time, the probe discovered that Jupiter has a ring system. Previously, scientists didn't know this. Then the spacecraft began studying Saturn. In 1980, the probe reached its closest distance to the planet, 64,000 kilometers, flying up to the upper clouds. The spacecraft took high-quality photos of Saturn's rings and some of its moons, and sent the data back to Earth. The temperatures on the planet itself were quite low. In the upper layer of the atmosphere, it dropped to minus 191 degrees Celsius. The warmest area was not far from the North Pole. There, the temperature was only minus 10 degrees. Very large, powerful winds were also observed closer to the equator, moving at a speed of 1,800 kilometers per hour. Voyager 1 also happened to be near Saturn's moon Mimas. It was notable for having a huge crater with a diameter of about 100 kilometers. At the same time, the diameter of the moon itself is just under 400 kilometers. In the Saturn system, the spacecraft's final target was the moon Titan. The minimum distance between them was 6,490 kilometers. As a result, it was found that Titan is not the largest moon in the solar system, although scientists previously believed so. The honorary title went to Ganymede. Voyager 2 also studied the moon's atmosphere and found that its density was higher than initially thought. Based on the data obtained, it could be concluded that there might be various bodies of water on Titan, but they would consist of liquid hydrocarbons. The fact that the probe got so close to Titan was not without consequences for it. After that, it could no longer study other celestial objects. Meanwhile, Voyager 2 was heading toward Neptune. It also got very close to it, at a distance of just 5,000 kilometers. We received an image of Neptune, where you can see a spot of incredible size closer to the equator. According to calculations, even Earth is twice as small. What is this? This is an atmospheric anticyclone. Its appearance specifically on Neptune is not surprising, because the most powerful winds in our planetary system rage on the planet itself, 2,400 kilometers per hour. Voyager 2 discovered 4 moons. Triton was also studied. It turned out to have geysers, and they were active. This was unusual for an object located so far from the Sun. The Voyagers completed their main missions and continued to operate beyond that. In 1990, we received many images of the solar system from Voyager 1. One of the most famous was a photo called the pale blue dot. That dot was our planet, photographed from a distance of about 6 billion kilometers. From that far away, we see Earth as a blue, unremarkable speck. By 2011, Voyager 1 had traveled about 109 astronomical units away from Earth and ended up in the stagnation region, a zone with a strong magnetic field, after which interstellar space begins. In the stagnation region, there is an increased level of high-energy electrons. They get there from the interstellar medium, which allows us to call this area the outermost region in our planetary system. However, even after reaching such a distance, the probes continued to make discoveries. In 2019, Voyager 1 approached the outermost area of the stagnation region, coming as close as possible to interstellar space. At the same time, the instruments on the probe reported a 25% increase in the strength of galactic rays, indicating that the spacecraft was approaching the edge of the heliosphere. It is now confirmed that Voyager 1 is already traveling through interstellar space. What's going on with Voyager 2? When the spacecraft was near Neptune, the planet's gravity changed the direction of the probe's flight. As a result, Voyager 2 moved away from the plane of the ecliptic and could no longer approach other planets in the solar system to study them. Nevertheless, this did not make the spacecraft useless. In 2018, it crossed the heliopause, the region considered to be the boundary of the heliosphere. After that, Voyager 2 also entered interstellar space. Thus, we were able to obtain important information from both spacecraft about cosmic winds and the properties of interstellar plasma, as well as the sounds of interstellar space. Let's take a closer look at the last one. The plasma wave sensor on Voyager 1 detected some oscillations of ionized gas in the region of interstellar plasma. Scientists were able to determine the intensity and volume of these sounds. This data also helps to determine the density of regions of interstellar plasma. These sounds are within a range that humans can hear, so we suggest you listen to them now. Amazing, isn't it? However, even though the Voyagers may not send new data to Earth for several months or even years, after some time we will once again learn many amazing and sensational things thanks to them. In 2022, a constant, although very weak signal was detected between bursts of solar radiation. It is assumed that fluctuations in the interstellar gas triggered the appearance of plasma waves, creating this hum. But what is it? It was previously assumed that the low-level activity occurring in the interstellar medium was lower than it actually turned out to be, even though we can consider this area a vacuum. We don't know the exact reasons for the increased activity. There are theories that this was caused by quasi-thermal noise created by electrons moving in the plasma, or by plasma oscillations in which thermal activity is observed. By studying this signal, we can also determine how dense the plasma is in the interstellar medium. The Voyagers recorded an increase in electron density in this region. This will help scientists in the future to learn how interstellar plasma is distributed and how it is affected by solar winds. Unfortunately, most of the sensors and instruments are currently turned off on both probes. Only those that study the properties of plasma are still operating. Before the Voyagers run out of power completely, scientists will extract absolutely all the data that both spacecraft have collected. Despite this, the radioisotope generators will continue to produce heat for some time. This could be about 880 years or 10 half-lives. Then the plutonium reserves will be completely depleted and we will never hear anything about these amazing devices again. For some time, the Voyagers will move in the same direction. They will pass through the Oort cloud together, where they may be damaged. But we hope that won't happen. After that, the spacecraft will fly in different directions, approaching distant cosmic objects. But unfortunately, we are not destined to find out what they will discover there. Earth is the perfect planet for human habitation. Do you agree with this statement? It would seem that its truth is obvious, but things are not so clear-cut. Indeed, considering our planetary surroundings, Earth seems like a unique island of life and natural grace. But is the universe really incapable of creating something more perfect for the existence of the human race and the emergence of life in general? Undoubtedly, it is capable. It's just that due to our technical limitations, we are not yet able to discover such objects. Although there are still a few planets on the radar. But first, we should determine which characteristics of Earth need to be improved so that we can live even more comfortably. What should our planet be like? Should it be warmer, more humid, or larger in size? Maybe it would be better to warm it with a star of a different type. Searches like this with the right parameters will soon be handed over to the newly launched James Webb Space Telescope. But scientists have different goals. To find out which exoplanet would suit us better than Earth. Here's a little spoiler. Later in the episode, we'll discuss objects already identified as candidates for this role. By the way, a signal was received from one such planet, Gliese 581d, a few years ago. Scientists are still debating how to interpret it, as white noise or perhaps as a greeting from an extraterrestrial civilization. The object is located in the constellation Libra, about 20 light-years from Earth. Astrobiologists from Queen Mary and Hertfordshire universities believe that the planet could very well be habitable. despite the fact that Gliese 581d is located on the edge of the Goldilocks zone of its parent star. The received signal was very cyclic and orderly, so there is every reason to believe that it has an artificial origin. So, what should we pay attention to first when searching for ideal exoplanets? The star that illuminates them. Our Sun is a G2V star, or a yellow dwarf. Compared to inadequate and unbalanced brown or red dwarfs, it is hotter and more stable. But there are stars in the universe with even more suitable characteristics. For example, K-type stars. Their lifespan reaches up to 70 billion years. That's 7 times longer than the Sun's. Stars of this type include orange stars, from dwarfs to supergiants. The temperature on their surface does not rise above 5,000 Kelvin. For comparison, some areas of the Sun heat up to 1,520,000 Kelvin. Not to mention the corona, where temperatures soar to as high as 20 million Kelvin. In terms of composition, such stars are somewhat similar to G-class stars, but there is little hydrogen in their cores. Remember the history of our planet. What cataclysms has it gone through during this time, and why? Many of them happen because of abnormal solar activity. With K-type stars, there are no surprises like ice ages or planet-wide droughts because their lives are smoother and more balanced. So nearby planets have much more favorable conditions. That's why members of the SETI projects mainly search for extraterrestrial civilizations near orange dwarfs. Are there many such stars within the Milky Way? Scientists say the number is just over 15% of the total number of stars. As an example, we can mention Alpha Centauri b, which is located 4 light years from Earth. And what about the planet itself? What characteristics should it have to become the best candidate for life? First of all, we indignantly rule out celestial bodies that are too old. Geological processes on them slow down over time, as a result of which the magnetic field may disappear completely. The latter statement means one thing: humanity, or whoever lives on this planet, will very soon turn into a handful of dying invalids, afflicted by radiation sickness from cosmic rays freely reaching the surface. So what is the optimal age of an exoplanet that is meant to become our new cradle of life? Approximately 58 billion years. That is, essentially, it should be about the same age as Earth or a little older. This factor is also related to the evolution of species, which needs time to develop. Remember how long it took for Earth's microorganisms to evolve from a vague primordial soup to upright humans, and even more so to intelligent beings. According to rough estimates, this process took 3.7 billion years. It's also necessary to take into account the time required for the formation of the planet itself. If you add the lifespan of the star to this scheme, as well as certain periods of its development, the ideal formula becomes much more complicated. Now let's talk about size. Do they matter? When it comes to exoplanets suitable for life, yes. For example, it is believed that celestial bodies that are about 10% larger in volume than Earth are an excellent option in this case. Why? First of all, such planets have stronger gravity, which means they retain their atmosphere much longer than Earth. Current data shows that our planet is losing its atmosphere at lightning speed compared to neighboring celestial bodies. It's likely unnecessary to explain where this could lead. The heat of the core also directly depends on the size of the planet. Larger objects retain it for a longer time. Now let's turn to more specific characteristics, such as the planet's surface temperature and humidity. Remember which regions of the Earth are most densely populated with living organisms. Absolutely right, it's the tropics. By analogy, we can assume that hotter and more humid planets have a high chance of developing complex and diverse forms of life. What is the average temperature of Earth? It is about plus 14 degrees Celsius. Add just about 5 more degrees and the planet will be close to perfect. However, you have to take into account an important fact. All of this is true only if there is water. This leads to the following point. The smaller the continents, the higher the chance for a diversity of life forms to emerge, because the age decreases. It's possible for uninhabited desert regions to appear. We have listed an approximate set of parameters that James Webb will rely on when searching for potentially habitable exoplanets. 2 important indices will also help it: Earth similarity and planetary habitability. By the way, the latter takes into account a wider range of objects where life could develop based on other chemical processes. For example, it could arise on objects that are much hotter or much colder than Earth. But that's all theory. But what about in practice? There are already real candidates for this vacant position. And the first one is Kepler 442b. The huge planet is located in the constellation Lyra, quite far from Earth, at a distance of 1,120 light-years. It orbits right next to an orange dwarf star. Its size is also similar to Earth's, but larger. Kepler 442b is 1.3 times larger than our planet. It goes without saying that this planet is located in the Goldilocks zone, that is, in the habitable zone of its star. Therefore, the conditions on it could very well be similar to those on Earth. The next candidate for the title of ideal Earth is the planet TRAPPIST-1I. However, the star that gives it light is a red dwarf, and those are quite unpredictable fellows. The exoplanet is located in the constellation Aquarius, and its diameter is close to that of Earth. If this planet has a dense atmosphere, then there could very well be water. And where there's water, there's life, at least in forms familiar to us. Is there a list of habitable planets? Yes, it has been compiled, although there isn't much data. In addition to the mentioned objects, it includes Gliese 667, C. Kepler 296, E. Teegarden b, and others. But astrobiologists often ask themselves an uncomfortable question. Does life really have to be like it is on Earth, necessarily developing according to the known laws? What about alternative biochemistry? With this turn of events, the list of exoplanets could be expanded endlessly. However, let's temporarily ignore these statements and summarize what has been said above. What are the main criteria for habitable planets? And in what cases can they even be better than Earth? The first factor is the energy source. This means the parent star, including the distance to it and the type of object, as well as the internal resources of the celestial body. Let me remind you, orange dwarfs are considered ideal here. The second factor is the presence of water in an atmosphere. The third factor is the planet's characteristics, such as its mass, geochemistry, orbit, and rotation parameters. The galactic environment of the object is also important because if there is a supermassive active black hole nearby, a supernova appears, or there is a powerful source of gamma radiation that sterilizes everything in its path. Then the chances for the development of life are extremely small, no matter how perfect the other conditions are. Be that as it may, despite all the extensive theorizing by astrobiologists, for now, Earth remains the perfect home for humanity. Of course, this does not in any way hinder the search for something new and possibly better. Wherever you are right now, whether in the scorching heat of Africa, among the harsh archipelagos of the Arctic Ocean, or in the mystical Himalayas, look up at the sky. It is adorned with a magnificent necklace of trillions of stars, but there is one spot unrelated to the celestial bodies that cannot be seen with the naked eye. This is a man-made object, the most distant human-made spacecraft from Earth. We are talking about the American space probe Voyager 1, launched in 1977. Do you think it has been silent for a long time? You're mistaken. The probe is still sending signals to Earth, and sometimes they puzzle astronomers all over the world. For example, recently Voyager 1 picked up a steady hum of unknown origin. What could this mean? Astrophysicists are still puzzled. What task is Voyager 1 supposed to accomplish? And where is it now? The main mission of the spacecraft was to study the giant planets Jupiter and Saturn. It is worth noting that Voyager 1 fulfilled its mission brilliantly. It was Voyager 1 that gave the world detailed images of the massive celestial bodies made of swirling gas as well as their rocky moons. But that was only the first stage. The most difficult part was still ahead for the probe, and it only began its crucial mission relatively recently. Voyager 1 was given a huge responsibility to study the Kuiper Belt and the boundaries of the heliosphere. But how can we interpret the data obtained if no one has ever been to regions of space so far from Earth? In a sense, it's like traveling with an incomplete guidebook where the majority of the information is simply missing. It was there, billions of miles from its home planet, that Voyager 1 detected a persistent hum coming from an unknown source, which most likely originated from interstellar space. In 4 decades of travel, the spacecraft has recorded various signals, but this is the first time it's detected one like this. And considering that Voyager 1 is literally feeling its way through those regions, places where the entire solar system, led by its star, will eventually arrive, the information it has gathered becomes especially relevant. Would you like to learn more about what Voyager 1 is studying? Our planetary community, led by its parent star, is located in a global bubble called the heliosphere. Under the protection of this invisible shell are all the planets of the solar system, along with the Kuiper Belt. It reliably shields these objects from the hostile interstellar environment. So what is the heliosphere and what are its characteristics? It's a vast region where the solar wind plasma moves at supersonic speeds. At the boundary with interstellar space, the solar wind collides with the plasma and magnetic field of open space. To put it simply, the solar wind accelerates to high speeds, twists into a spiral, and then suddenly slows down as it hits an invisible barrier, gradually mixing with cosmic particles. Voyager 1 is currently located in the region where these events are taking place, which means that's exactly where the spacecraft detected the mysterious signal. How difficult was the journey for the spacecraft before it reached the outskirts of the solar system? Where has the probe traveled and what stages has it already passed? In 2004, Voyager 1 crossed the termination shock, the region of the heliosphere, where the solar wind begins to slow down significantly, anticipating its encounter with interstellar matter. How did scientists on Earth discover this? Of course, the conclusions are based on the readings from the space probe. Yes, as mentioned earlier, after 43 years, it is still sending signals, although not all the sensors on board the spacecraft are working properly. Anyway, let's continue. Beyond the shock wave lies the heliopause, where the solar wind finally calms down and mixes with the matter of deep space. The structure described is known to astronomers indirectly, since apart from Voyager 1, no other inhabitant of Earth has ventured so far into the pitch-black darkness of the universe. That makes its message all the more valuable to us. For example, there is a hypothesis that beyond the heliosphere, at the boundary of the solar system called the bow shock, there is a hydrogen wall filled with hot gas. Isn't that what the hum from Voyager 1 conveyed to us? The signal consists of vibrations in a certain frequency range, and it could very well serve as confirmation of this theory. Unfortunately, it's impossible to measure the pressure, density, and temperature of the plasma because the instrument on Voyager 1 stopped working back in 1983 years after launch. But the other instruments are still active and scientists rely on them. The plasma wave instrument and the cosmic ray detector are still diligently sending us information. Thanks to the latter, it was possible to record an increase in the level of cosmic rays and high-energy electrons when Voyager 1 was approaching the boundary of the heliosphere, which it successfully crossed on August 25, 2012. The probe's power supply is provided by radioisotope generators running on plutonium-238. At the moment, their power has decreased by half. But let's return once again to the mysterious hum detected by the Voyager 1 spacecraft. What hypotheses, besides the ones already mentioned, do scientists consider to explain this strange phenomenon? The fact is that similar vibrations can also be caused by plasma waves of various kinds. For example, they can be triggered by major solar flares. Some astronomers suggest that the space at the boundary of the solar system and open space has a structure similar to foam. This happens because small cosmic objects form small spheres around themselves, similar to magnetic bubbles. It is possible that this also leads to the appearance of strange vibrations detected by Voyager 1. By the way, the sound of the mentioned signal is similar to a distant ringing, periodically interrupted by strange irregular bursts, resembling the striking of a bell. It gives the absurd impression that someone is sitting on top of the space probe and banging on its hull. Has the spacecraft from Earth finally left the boundaries of the solar system? Not at all. According to NASA's calculations, this will happen in about 30,000 years. Right now, the probe is passing through a kind of cosmic inferno, but unlike the companion in Dante's Divine Comedy, the spacecraft is completely alone and has no companion whatsoever. The boundaries of the solar system extend much farther than the Kuiper Belt and even the heliosphere. It will take about 3 centuries, and Voyager 1 will plunge headlong into the Oort cloud if it exists outside the imagination of scientists, since no one has actually seen this formation. It is believed that the comets that sometimes enter the solar system are actually guests from this very cloud. What will happen next? As soon as Voyager 1 leaves the boundaries of the Titanic Thor, the spacecraft will embark on an eternal journey through the Milky Way, and we are unlikely to ever learn of its fate unless the golden record with Earth's sounds and other information falls into the hands of extraterrestrial civilizations. Unfortunately, modern astronomy is in many ways like reading tea leaves, although of course the science of the stars has advanced significantly compared to previous centuries. It's hard to imagine what else Voyager 1 will discover on the outskirts of the solar system, and most importantly, how can we decipher these signals? For now, the spacecraft is about 20 billion kilometers from Earth, cutting through space at a speed of 60,000 kilometers per hour. Its research is very valuable for science, because thanks to it we can lift the veil of mystery a little and learn what interstellar space is made of and how it behaves in its natural environment. In addition, this will allow us to take past mistakes into account when designing new probes that will be even faster and more reliable. And while Voyager 1 literally has a ringing in its ears, let's enjoy the comfortable conditions on Earth and the ability to easily get any information about the vastness of space without leaving our favorite couch. The Hubble channel is glad to bring you this content and would appreciate your likes and subscriptions. Don't miss the most interesting part.